John and I have worked on a couple of projects together, and I'm going to go through some of the screens and barriers that we've worked on, and then John is going to go into a case study that is quite informative on many levels for what you can run into. First off, I'm going to just look at the expensive stuff that I would probably use at home. Especially the rotating screens are on most hydropower dams in the U.S. Extremely expensive, high maintenance. They use those to screen fish from the intakes, put them through a bypass that goes around the dam and dumps them on the other side. Not even considered here because of the cost. The other one is the electrical barrier. I've worked with Smith Root a lot. Never been 100% effective. It wasn't effective for the silver carp incursion in the eastern United States, but an option I don't think would ever happen here because of the cost and public hazard. One that I'm really surprised hasn't been more used to prevent the spread of pest fish here is the drum screen, and that's probably because no one's set up a company to make these yet. But the drum screens are used all over the northwest of the U.S., mainly to keep salmonids out of irrigation canals, but they have also been used successfully to prevent incursions of pest fish, especially carp, getting into wetlands. And the idea here is that drum rolls around and it dumps debris over the top, and they can be powered by paddle wheels, or the one in the bottom right is solar. So a really good option. Most of these are down to 3 mil, but I think they'll go. You can get a screen, depending on the side, but pretty simple. This is another version of that same drum screen. The problem with this one is it doesn't necessarily dump that debris over the top of the barrier. That's the advantage of the drum screen, is it rolls the debris downstream, but doesn't let fish come up. Another one that I have designed basically to be used for a new incursion. We designed one of these for the Corps of Engineers when the silver carp, was starting to move up the Mississippi, and the idea was a side channel about the size of the one in the lower right, was that you just block it with dirt, riprap, and have a self-cleaning screen on one side that prevents fish from getting through to your downstream site or the upstream site, depending on how you orient it. But another option, but again, very expensive, and it requires a power source in almost all of these, or a water source to flush the screen. On the more practical side, something that we have implemented here has been barriers. So if you have a 1 meter barrier, you can generally stop carp from getting through. And there is a couple of issues with these, native fish passage. We're going to talk about that on the next slide, but they're pretty low cost. They are effective if you have that height. Unfortunately, getting a 1 meter head height in the Waikato can be challenging, but they can be enhanced with these jumping bars that you see here across the top of this conceptual design. A gabion basket stilling basin is another one if you have a bit more depth. Using that gabion basket stilling basin, you could, in theory, if it doesn't silt up, reduce the run-up the carp get to jump at it if you have under a meter. And then the addition of an Elver pass. And that came up in the last time we looked at one of these. Is the Niue team had said they wanted a 60-degree ramp, which is great for passing Elvers, but my thought was that in the application that we were putting this into, we were more worried about carp getting into this lake than we were having an Elver problem, because we have other means or retrofit this to pass Elvers at a later date. So I was going for a 15-degree ramp or less with brush. But since then, I found this design online. I don't know, has anyone seen one of these yet? It is a variable height weir. On the right-hand side, there's a little crank, and that cranks that bucket out to tip it. And the black thing on the left is an Elver pass that adjusts with the height of the weir. So really neat additional sort of design there that would probably solve that problem. You'd get the 60-degree slope and still be safe here in terms of pest fish passage. So a great idea. This is out of a company in the UK. And another option that we've thought of, and I've heard that someone tried this down on the South Island for a trout barrier in Dunedin, but a weir If it was less than 1 meter, John's going to get into why we came up with this idea or considering it, that then poured through a very porous gabion basket. That would make a stilling basin that wouldn't allow adult fish to run up and jump at the less than 1 meter weir, and still allow pretty easy access to juvenile fish to get up through, and native fish. You'd probably add some sort of brush overpass to this as well. In that, leading on to another option that we have tried here is the one-way barrier, and this particular one came off of Leith Waits' idea with a cage, carp cage, same thing that Bruno's using for the trap, and this was an afterthought to the Ohinewai fish removal project that John came up with the money and Kevin to put this in, and we did this original barrier for $5,000 installed, so extremely low cost, and designed it, on Google Sketch or something at lunch. So it wasn't meant to be that successful, but apparently I think Grant's going to talk later on the. Yeah, I think it's worked better than I had hoped for. Low cost, low maintenance. The idea is that the fish go out, they can't get back in. And it can be retrofitted. This is on a 1,300 mil culvert. All we did was lower it in and bolt it into place, dyno bolt this into place. So pretty easy setup, and the 2 rods out front. Luckily, this had some hard pan underneath it, so we were able to support the weight of that with a couple of rods out front with platforms on them. And it seems to be effective. This is Lake Ohinewai. We're not going to go too far in. Do you want to take over from there? Yeah.
So this screenshot is taken from the WAMS website that Adam referred to earlier, and I put it up just to sort of demonstrate some of the practical difficulties we have in managing our lakes. So the dark green is the dock-administered reserve. So you can see from that fundamentally dock administers the lake water body and a very narrow margin around it. And our only access is through this paper road here. And so that, again, is typical of the fact that we are totally reliant, generally speaking, reliant on good farming relations. And so the light green is a recreational reserve administered by the Waikato District Council, but it's dairy farm, and it's surrounded by a sea of dairy farms. And so the outlet of the lake is there, and that leads across the road, thence onto Lake Waikari, which in turn is connected to the Waikato River. So clearly, very easy koi carp access to this lake. So the barrier that we put in is just on the roadside, just up here. And so this is the design, and Adam's just lifting it up to clear some weed out of it, but fundamentally those weighted bars are just unidirectional. They just move downstream, so any fish can push them and go downstream, but adult koi cannot go upstream. But certainly large eels do have the ability to go through this screen. So most times you visit there, there's koi carp pushing up against those bars. And occasionally, though, there is the issue of weed pushing, coming down the stream, particularly in the autumn when you get that dieback of aquatic weeds in the drains, pushing it up against it. So again, it's a relatively easy barrier to clean. You just crank it up to let that flush of weed growth go through. So it's easy to maintain, and even with a major flood event, very little debris accumulates. The next site that we've both worked on is at Lake Serpentine, Rotopiko. And the situation here is that this is Lake Serpentine. It's a high value lake. It's 17th out of 169 lakes measured nationally for the Lake Submerged Plant Index. So it is the highest ranked lake in the Waikato for macrophytes, and it scores about 15th out of 96 lakes in the Waikato region for biodiversity value. So extremely high value lake, and it is actually a lake complex as well. And like all lakes, it didn't have any natural outlets, but subsequent agricultural development has seen a drain push through here and into Lake Rotopiko, and then Rotopiko in turn is connected up to the Waikato River, and koi carp have been found in the drain leading into Rotopiko. So the potential for koi carp to get into this system was very real. So that was why we wanted to put in a barrier to stop invasive fish getting up into the Lake Serpentine complex. Just to sort of go over again the context of this drain. So we've got the Lake Serpentine weir here at the outlet of Winter Lake, and Rotopiko down here. And we held a workshop to figure out where we put a barrier, and our minds were focused on the weir area. But the problem there is that it's low-lying, it's peatland, it's thick peat, probably 6 to 8 metres thick, and it's flood prone. And any barrier we put in is going to be on private land, so there was all sorts of complications about how you manage put in a barrier that was low cost, low maintenance. But a hydrologist, Murray Mulholland from Waikato Regional Council, did some thinking around this and suggested why don't we put it here, downstream of a farm culvert that was built in the 1950s. And that appealed to me because any flood event is going to be held up by that culvert. So anything I put downstream is going to reduce the liability it might have to causing some sort of flooding event on farmland. So that's where we focus. It also had a natural fall height. And so that's the site there. So we're looking at a site 2 kilometres downstream from Lake Serpentine, and this is where I wanted to put the barrier. I didn't want to put it too close to that kahikatea tree there because I didn't want the interference from the roots and drive the piles with the barrier. I didn't want to put it any further downstream there because clearly that's a lake, former lake edge, and the word maneuver, the distance there floats right up to that edge sometimes. So that was my preferred site, quite a deep incised cut. I sought advice as to what kind of barrier. One recommendation was that I put in a aggregate concrete rear front. I didn't like the idea. I was nervous about that idea because I wanted a structure that was flexible in its modification, if you like. Having a concrete structure was not going to give me easy flexibility in raising and lowering the weir crest. And there was issues around the desalting behind the dam, although you could put a mud pump in the back of that to sort that out, probably. The other aspect was being concrete. It was going to cost me 5 times the cost of a wooden structure, and further to that, it was going to be on private land, and the farmer concerned wasn't prepared to give me a right-of-way or any legal right of access. So this is the structure we came up with, and myself and others, with the support from a registered engineer, because we needed that to get a resource consent. So it's just a vertical slotted timber structure with cone-type bars on the top, and at the bottom here is a Reno mattress, a Reno concrete mattress, so it didn't give me plunge pool development. And in the centre here is 100 millimetre long nylon brushes to allow Elver passage. That's the back of it. Wasn't without its difficulty in construction. We had to put this cardboard casing down to drill the hole to then drive the piles, 3 metre deep piles, but we found after about a metre of going through yellow, brown, firm clay, ash, weathered ash, we went into unconsolidated grey slop, really, full of lacustrine sediments. So it was quite a flurry of activity to drive these piles down quick enough and pour concrete down to set them in place. But nevertheless, this is the result, and we were pretty pleased with the result at that point. The problem was that in April, May last year, there was a period of sustained rainfall, nothing like the preceding year, but given there's a sustained period of rainfall in 2 weeks, it caused flooding in a paddock about 1,400 metres upstream and about 200 to 300 metres to one side, and that proved to be the area in which the former Round Lake existed. This was a lake that was drained in the 1930s. And this is the drains filling. And so the farmers' reaction to that, notwithstanding the fact that we had record lake levels all around the district at that time, the farmer's reaction was to get out a chainsaw, so to relieve the pressure from the flooding event. So my view about that at the time was, well, you know, if the guy's so stressed out that he had to take that kind of action, let's think about it and understand it from his perspective and see if indeed this barrier was causing the grief or not. And what it showed was that the hydrological model that was produced, notwithstanding the fact that we had detailed survey data on the drain, was incorrect. That the former Round Lake was at a level not to very fine connection between the Round Lake and the former Round Lake and the drain water levels. So we were indeed causing a problem. And so as a consequence of that, a rerun of the hydrological model showed that we need to revise our head height on our structure. And the last thing I wanted to do was create a liability for myself in terms of causing any flooding upstream. And it was important for just the whole farmer relations thing that we are long-standing neighbours and we have to work with each other. And so that showed that even without a weir, flooding occurs on that side. On that northern side of the drain, there's 6 to 8 metres of peat, and on that side of the drain there used to be a row of eucalyptus trees that was further subsidence of that peat. And so the barrier now is going to be set at that red line where all the parties agree that I'm not going to cause any flooding. So the revised design is pretty much the same as before, except for the fact that we're now lowering the crest height to 52 RL, so that I'm not going to cause any flooding on this land. And because of that reduced fall height, I'm going to place a gabion basket over the Reno mattress. So it's going to be a 2.5 metre long gabion basket, which will contain 200 millimetre plus rock, from which water will just flow through. So this summer, this is what we're going to do, and hopefully this time next year we'll be able to monitor it for recovery passage and so on. But it's quite a saga, and the cost of construction of the barrier is about a quarter of the total cost. Everything else was surveying and consents, and engineering design, and expensive fishery scientists design.